Good afternoon, students. In this video, we will be discussing the evaluation of seam strength. In the last video, we had discussed that what is seam, what are the different seam classes, and why it is important to evaluate or determine the seam strength. So basically, why does seam failure occur? Seam failure occurs if wearing out or falling of the sewing thread before the fabric takes place, before the fabric tears or the fabric has good tensile strength. So the fabric is durable, but before the fabric can break or tear, the sewing thread which makes the seam, if it wears or if it fails, that can be one of the reason of seam failure. Yarns of the fabric break or damaged by needle during sewing. As we all know that during the sewing process, the machine is operating at quite a high speed and there are a lot of chances of mechanical damage because of the high speed of sewing. Needle gets heated up. In such cases, if the yarn of the fabric breaks or if it gets damaged by the needle, so that can be one of the reason of the seam failure. So occurrence of seam slippage. Seam slippage is the condition where a seam sewn in the fabric opens under load. When some load is applied in this portion, where the seam is applied, so if it opens up, so this is the prevalence of seam slippage. More problematic for fabrics made from slippery yarns. This condition is more severe in cases when the fabric is made of slippery yarns, it has an open construction, or it has low warp and weft interlacement. Any kind of structure which has low warp and weft yarn interlacement, a low cover factor, or long floats. So in such cases, the problem can be more severe. So the seam slippage or the seam strength test can be classified into three types. One is where a standard seam is put under load and the seam gap is measured. The second one is where the load extension curve is plotted with and without the standard seam. In one of the sample, the seam is applied and another is seamless sample, and the difference between the two curves is taken as seam slippage. The third one can be where the measurement of force required to pull a set of pins through the fabrics is determined. So the second one is the most prevalent, which is used, and this is generally carried out on a standard tensile strength tester, on which the value of load extension can be had and the seam strength can be determined on the tester. So this slide is basically showing that how the sample is prepared for the seam strength measurement, and this is how the samples are clamped between the two jaws in a tensile strength tester machine. So this is the unseamed fabric sample where no seam has been applied, and this is the sample where two fabrics have been joined by the application of seam. So usually here a sample of 250 mm by 100 mm is taken, and this is how the fabric is folded. This shows the seam line. It has been folded to a length of 100 mm, and then the stitching line is applied in order to form the seam, and 5 warp and 5 weft specimens, each of the dimensions as shown here, are taken. So out of this 50 mm length which is taken, the 100 mm will be folded in this way to form a seam. Each sample is folded 100 mm from one end and a seam is sewn 20 mm from the this is the 20 mm distance that is taken from the fold line using the special sewing thread and sewing machine. After sewing, the folded part of the fabric is cut away 12 mm from the fold line, leaving the seam 8 mm from the cut edge. This is shown here. A standard strength tester equipped with 25 mm grab test jaw is used, and the gauge length being set is 75 mm. The gauge length is the separation between the top and the bottom jaw, which is kept at 75 mm here. So this is the method I was referring to, that is where the load elongation curve is plotted, one for the seamless sample and another when the seam is applied on the fabric, like this case and the one where the seam has been applied. For these two individually, for each one of them, the load elongation curve will be plotted without a seam on the fabric, and the other one where the seam has been applied using this method. So the sample without a seam is first traced in the tensile tester up to a load of 200 newtons and a force elongation curve is drawn. This is showing the force elongation curve. The sample is made to extend up to a load of 200 newtons and the force elongation curve is recorded. This is for the sample where the seam has not been applied. And this is showing a closer view of the tensile strength tester, which consists of the load cell, the upper and the bottom jaw, and these are showing the clamps, and this is how the specimen is mounted in between. So the matching sample with a seam is then tested in the same way. The another sample on which the seam is applied is also tested in the same way. That is, it is subjected to a load of 200 newtons and the load elongation curve is plotted for the other sample which has a seam applied to it. And it has to be ensured that the force elongation curve starts from the same 0 point. Comparison can only be made when the two force elongation curves, one without the seam, the other one with the seam, if they start from the same starting point, that is from the same 0 position, then this horizontal gap between the two curves, that is this one and this one, so the horizontal gap between the two curves will give an extent of the seam opening, that because of the application of force how much the seam gets opened. So this can be have had from this horizontal distance or the gap between the two curves, one without and the other one with the seam. The horizontal separation between the curves is due to the opening of the seam. In order to find the force required to open the seam a given distance, so we need to find out that how much is the seam opening. So how it is assessed? The separation of the curve at 5 Newton is measured. The separation of curve when it starts from the same point 0 is measured at 5 newtons and then at 200 newtons. In order to find the force required to open the seam at a given distance, the separation of the curve at a force of 5 Newton is measured and this distance is added to the seam opening specified. This seam opening is specified in the standard, which is 6 mm. So 6 mm plus this distance is added to it. Next, the point on the curve where there is the separation of this distance is located and the value of the load at this point is read on the chart. So this can be beyond 200 newtons or this can be anyway down the line, that is below 200 newtons. So this point where there is horizontal separation between the two curves is noted, and analogous to that, what is the force that can be determined from this y-axis. So the point on the curve where there is separation of this distance is located and the value of load at this point is read. For example, here it is showing this point where the value of the load can be determined. If the curves do not reach the specified separation below 200 newtons, then the result is recorded then more than 200 newtons. So from this we can obtain the seam efficiency also. What is seam efficiency? The force is applied until the thread breaks and the seam failure occurs. The amount of force required to break the seam is noted as we discussed earlier. So seam equation can be calculated using this equation, which is but this is not, this method or this test method is not suitable for application on bound seams. What kind of seam is bound seam? Where the fabric edge of one fabric is bound or covered by another seam. So this seam is class 3, class 4. It is class 3 kind of seam which is used on t-shirts and all. So this is not suitable for bound seam, but other than that any other class of seam from class 1 to class 8 can be tested using this test method, and seam efficiency in percentage can be determined from seam strength to the fabric strength, or the force which is required to break the seam divided by the fabric breaking force into 100, that gives the seam efficiency. So this is all about the seam, the classification of seams, the factors which affect the seam strength, and then we have discussed how the seam strength can be evaluated using the standard test method. So this is all for today's video. Thank you.